Hello, everyone. Thank you all for coming. Let me adjust this. Yeah. So today we're going to talk about browser-based AI workflows and what that means. You will see a little bit later. So first of all, a quick word. I'm Jeremy, and I am working at QuantStack right now with about 30 people working on open source full-time, Jupyter, Apache Arrow, and Mamba and package management in the Conversational ecosystem. But personally, I'm more involved in the Jupyter front-end aspect of the Jupyter ecosystem. So it's JupyterLab, Jupyter Notebook, and JupyterLite. And recently, I've been looking into is this mic making the noise? I've been looking into AI integration in Jupyter, and more precisely in JupyterLite. So as you all know, the AI space is moving fast, or should I say very fast. It's like every day there's a new model. There are many different IDE integrations. Now we have like the TUIs, the CLIs, like Cloud Code, Codex, and so on. We now even have background agents running on people's cloud, and in Jupyter, it's a little bit of a different story. So you probably have seen the talks this morning about Jupyter AI and other kind of AI in Jupyter efforts happening right now. So I think in 2025, so currently it's worth mentioning Jupyter AI, which started out of this generative AI work in Jupyter. Currently, they're using they are at the version 2, and there's work on v3 to add a lot of agentic behavior, MCP, and so on, and using RTC. But I wanted also to mention other projects such as Notebook Intelligence, which was developed by a former Jupyter contributor, which I hope will come back and contribute to Jupyter AI contrib as well. And there are a bunch of other projects such as Mito AI, and maybe many others out there. But I looked at many of these projects, but none of them really fitted the kind of browser-based approach that I wanted to have, especially in the context of JupyterLite. So the question is, how do we make this work in JupyterLite? So this talk is not like we're showing you something that works and you can use it, production, and so on. It's more like a forward-looking view on what AI in Jupyter can look like. So it's just one of the possible views. And I think there are like many ways you can have AI in Jupyter, and we've seen some examples this morning. And this one is just another view of this. So a quick look at what we're going to cover. And for those who don't know, JupyterLite is a Jupyter distribution that runs entirely in the browser, and the kernels run in the browser as well via WebAssembly. So it's very convenient because then you just need to deploy a static website. There's no need to install Python on your machine, and everything runs in the browser, and you can even embed a Python console on your website, which is what we have here with a screenshot on the numpy.org website. They use JupyterLite, so it's easier for the users to try numpy. So how do we integrate AI in JupyterLite since we don't have a server running? So we started to look into this in this repo, which is just called JupyterLite AI right now for lack of a better name. And with this integration, you can chat with remote models just like with Jupyter AI. So you have access to a chat on the side. Maybe I can do a quick showcase here. Let me see. Let me refresh, that would be better. Yeah, I can just type some prompt. So here I've pre-configured some models. They don't run in the browser. So there is like an actual request made to the model providers, but directly from the browser, doesn't go through any other server running on the backend. And this is the default, it's kind of the thing you've probably seen already with Jupyter AI v2. Code completions is also supported. So if I'm not going to demo it, but here's a screenshot. It's like if you go somewhere in the code and then you want to have like something like inline completion to help you write code faster, this can also be integrated. Agent mode, everything is about agent in 2025. So what is an agent? It's pretty much just a while loop which calls some functions. And in this JupyterLite AI integration, what that means is you can do something like this, like I want to create a notebook about pandas, matplotlib, and then you have the notebook created automatically, and you can see also like what tool the agent is currently using to perform the actions. So I wasn't sure about the Wi-Fi. I think it's a little bit slower than what I expected. So hopefully we'll manage to go through the other demos. But otherwise, I have some backup videos. But yeah, here it adds cells one by one because there is like a tool available to the agent for adding cells. So while it's working, maybe I will go back here. So what happens if I want? Yeah, maybe we can just stop because it's taking a bit long time. Could you also ask the agent to clear the outputs of the notebook? So here it's not executed, but let's see. If it's too slow, I will move a bit faster, but maybe we'll have something working. So here what you see is that the agent is using a tool called discover commands, and what it's trying to do is trying to find what commands in JupyterLab are available to perform the actions that the user requested. So all of the commands are made available to the agents by default, but the agent can use a query. So here we see it's funny because it tried to use run all to query the command, it didn't find anything, and then actually maybe it found something. Yeah, it does. It did find like 7 commands, and then it executed this one. So this one requires approval because you can also imagine having like a whitelist of commands that you would like to execute, but then some that may be executing arbitrary code like this one. So here you can just approve or reject, and if you approve the agent loop, which is again just a simple loop, it's just continuing where it stopped. And there are some errors because the code, I think, was not correct that it generated. But that's okay. So here it tries to rerun. Yeah, it noticed that it didn't work, so that's why it's going to try to rerun again. And this command is also a command that requires approval, so that's why we have this. Okay, I'm not going to show more things about this because there are a couple of interesting things you can do with this is showing diffs. So we've been working on a package called JupyterLab diff, which simply exposes a bunch of JupyterLab commands to show a diff for a cell or for a file. And this is what the diffs look like. So this is a split view for a diff. And if I take this prompt and let's say open this file, this notebook, which is, let's say, a very short notebook about pandas, and let's say I want to convert it to use bars instead. What I can do here in the AI settings, I can check, yeah, I have the show cell diff enabled. So it's going to show me the diff when it makes changes. So if I run this, it seems to be a bit faster than earlier. Let's see. It's a couple of cells, so I don't know how long it will take. Yeah, it's trying to get some information about the cells. Let's see if we can get moving. Otherwise, I would just show you the screencast. But yeah. Yeah, I think it's taking a bit more, too much time, unfortunately. So with these diffs, it makes it a bit nicer to see what the agent has done, because otherwise you would have to use something like Git, or maybe like the JupyterLab Git extension with mbdime. But here, once you have this view, you can more clearly see what the agent has done, and you can also revert to the previous version if you are not happy. So here it's just showing the split view, but there is also a way to have unified diffs. So that means like you have your diffs not shown below the cells, but directly in the cell. So back to this idea of executing commands. That means that the LLM has knowledge of almost the whole JupyterLab environment, which is quite powerful, by just exposing these two tools, the discover commands and execute command, like we saw. And for now, we were just looking at examples of creating files and editing files. But here, I could also say toggle the write area. The write area in JupyterLab is here. So it's doing a query like this to search what commands are available. And I don't know if you noticed, but it opened the write area because it found the correct command to do this. You can also show the about dialog. So in JupyterLab, I think we have around 400 commands right now by default, but extensions can come and add more commands if they want to. Yeah, there you go. So that's, you're going to say, like, yeah, that's it's nice but not very useful. So we can go a bit further and let's see if, let me close this. What could we do that is more interesting? So there is a project called JupyterCAD, which lets you create files here and do some interesting 3D things in a browser. What if you could have the LLM work on that directly? So let's see if it's going to work. So here I have a prompt that is going to ask the LLM to build a chess pawn using JupyterCAD. So let's go back to the chat. It created the file. It's searching for the JupyterCAD commands. I found actually, I didn't know there were that many, 48. And it's laying out a plan to construct that chess pawn. So we see that my hands are here, so it's not me doing this here. Yeah, I don't have a secret button or whatever. Yeah. So it's just executing the commands that are available in JupyterLab. And I can just watch it work for me. Yeah. So this is one of the examples of, it's not just about code, generating notebooks and files. You can go, I mean, the possibilities are, I think, endless if you integrate something interesting in JupyterLab via the command system. Let's see. So all of this runs in a browser. The AI integrations are done directly. Here you can set up new providers. So we have a couple by default, but you can have provide more via extensions. And what that means is that you have a request going from your browser to, let's say, the Anthropic servers or the OpenAI servers. But you could also configure that with a proxy. For example, LiteLLM is a proxy that you can host somewhere on your infrastructure and configure the models somewhere on another server and have everything be proxied through for this. So I had a quick demo here. It's 30 seconds, let's see. Yeah. Yeah, on the right you have the LiteLLM proxy. On the left, we have the LiteLLM provider configured to route messages to this proxy, and then you can just use it like if it was a regular provider. Yeah. And here it's just showing the logs to make sure there is something happening on the proxy side. So this idea of having proxies, like you can have very lightweight deployments with JupyterLite and have a very lightweight gateway to maintain on your servers, which is a different approach compared to other AI integrations. So now a quick word about MCP. So MCP is a new standard, which is I think a year old, which is meant to aggregate tools together so that they are available to these LLMs. Like here it says on the docs, it's like a USB-C port for AI applications. And with this JupyterLite AI project, we are able to leverage some MCP servers that are not hosted necessarily on the same machine, but remotely. So maybe here I would just show the video instead of the demo. That would be a bit faster. Yeah, the network is very not cooperating very well. Yeah, here if I use a DeepWiki remote MCP server, DeepWiki is like indexing the Git repositories, and then you can ask questions about the Git repo. So here if I ask what are the changes in a specific repo, so here for example JupyterGIS, you see that it's using a tool provided by the MCP server, which is not hosted anywhere on my machine, but on deepwiki.com. Yeah. Okay, let's move on to the fun part. What about LLMs in a browser? So for now, we have only talked about accessing remote LLMs on providers, on website, or on servers somewhere, which we don't have control on, of course. So what if we could run LLMs in a browser? That means that we don't have dependencies on the server still. Everything about privacy becomes more interesting because then nothing leaves your browser. So in the web world, there are two major projects. One of them is WebLLM, and the other one is Transformers.js. They let you use usually the open weight models that are available on a Hugging Face. And here I can show you it's the same. Like WebLLM is using models that are around 1 gigabyte in size, so there is no way I can run that on conference Wi-Fi, of course. So I'm going to show you like this integration in JupyterLite AI. So when you use something like WebLLM, it's downloading the model locally. You can see here it's integrated with the JupyterLab notification. Here the video is sped up because it's taking more time than this, of course. But then once it's downloaded, it's going to be cached in your browser, and then you can reload the page and use the cached version of the model. So here it's using Llama via this WebLLM project here. But what if we could go like one step further and have built-in AI? So for those of you who like to live on the edge, without pun intended, of course. Chrome is experimenting with this idea of what if you could just ship an LLM to end users. So they are doing that with Chrome, and they are using a nano version of Gemini. And I think Microsoft is doing similar things with their Phi 4 series of models. What that means is that if you open your DevTools and you do a language model.create, you get one of those LLMs, and then you can prompt it with whatever you want. And it's not only about the prompt API. Actually, they are working on many other APIs which are can be useful for different use cases, like summarizing content, proofreading, and so on, translation. The big disclaimer right now is that everything is behind a flag. So in Chrome, you will have to go there and activate, enable the flags, but that's a one-time thing. Then you need to download 22 gigs of data basically just the whole model, and then you're good to go. So with this, you can generate code. So here I have, let me see. So we integrated this like hello world in JupyterLite AI. So here it's using this inference step is happening locally on my laptop in the browser, and you can chat with it. So it doesn't support tool calls yet, but they are working on it. So they will probably be available in a couple of weeks or maybe a month. But that's about code. But what if you could use these kind of new APIs for something else? So they have these models have also like support for image recognition and audio transcription. So what if you could just go there and let's see, do a bit of cleanup. What if I have this file and I have an image here, but you see that there is no alt text? That's not great for accessibility reasons. So I could just right click and generate alt text with Chrome AI. It's going to work. So here, at least I don't have Wi-Fi issues because everything runs locally. That's the good part. And you see that it replaced the markdown cell with the kind of summary of the image. So you could do this. Can you imagine having some kind of button that processes the whole notebook and fixes all of this stuff automatically? What else do we have here? I have a notebook with some typos. Like here you can see that it's wrongly spelled. So what if I click on this button here, which says proofread all markdown cells in a notebook? So I click on that. So it's working. You see the markdown cells are updated. So here there is also a typo. Yeah, and now it kind of autocorrects your notebooks very easily, locally. You may be wondering, like, what are those kind of shiny sparklers like here? This is making use of the summarizer API. So let's say you don't want to open a notebook because it's too annoying. You can just click on this. And it's going to use the summarizer API locally to compute a quick summary of the notebook. So here you can say fractals are endlessly complex, blah, blah, blah. This one about pandas. Yeah. What if you want to, let's say you have this audio file, you could have like a menu item, like it says generate a transcript. So it generated the transcript. Okay, maybe I should have played the file. Oh yeah, never mind, you got the ID. So yeah, that's built-in AI. And I'm super excited about this because, like, in combination with JupyterLite, it means that you could just ship a static website somewhere and you get all of this for free without having to set up any API key, managing data leaks, credentials, and so on. So for privacy reasons, it's a very strong case. And also for performance reasons, like if you are on sketchy Wi-Fi, like here, at least it's a bit faster, as long as you have good hardware. So now we're coming to all of the limitations of this in 2025. For Chrome AI, you need to download 22 gigs, which is quite a lot. There's like this upfront cost of downloading the model. There's also a question of performance. You need a good hardware and also a good GPU, ideally, because it's using WebGPU underneath. You need to enable the browser flags. And then when it comes to MCP, it's limited to remote MCP servers right now. I don't know. There is like a working group for everything about WebMCP, but I don't think there is anything concrete right now. Then there is a question of secrets management. So not back to the first demos on talking to model providers. The question is like, where do you store your API keys? So currently it's using the settings system in JupyterLab, which works with JupyterLite. And that means that the secrets are stored in a browser. But there is also a project to integrate with different kind of secrets manager. If you would like to store your secret somewhere else, you could write a custom connector to do this. And then the other option would be to use a proxy server like we saw earlier. So what's next? In the case of this browser-based, more JupyterLite-focused kind of integration, there is also a question of real-time collaboration. So I think at some point there will be an integration with WebRTC, so you can also collaborate with other people and agents running in your browser. Yeah, the Chrome AI and Edge AI, they don't support tool calling yet, but I think it's just a matter of time until they do. And then we're also experimenting with, since currently the trend is CLI tools, what if you could have like the JupyterLite terminal run one of these AI models, like if it was running Cloud Code. So Ian in the room has been working on this, so he's been working on a JupyterLite terminal, which lets you run the terminal in the browser. But here it's a quick proof of concept of what it would look like if you could also, have this kind of Cloud Code or Codex workflow in the browser if you prefer that than the chat like we were using before. Okay. So that brings us to where do we go now from there? So maybe you've seen the talks from the other sessions. There is ongoing work on making more building blocks for AI in Jupyter, so we can share more things between different use cases and projects. So for example, the diff extension can be used in this particular case, but also in a regular Jupyter AI on a regular Jupyter server. And as an extension author, you can imagine providing more functionality to LLMs by just writing new JupyterLab commands in extensions. And then there will be also the idea of what about hybrid workflows? So what if I want, I don't know, like the Jupyter AI personas on the server, but I also want this quick proofreading models happening on my browser and have them, be able to choose one or the other, or have some kind of higher level system that chooses the right approach for the job. So we are going to work more on this at the sprint. So if you are interested in all of these things, join us. And that is it for today. If you would like to play with this, so all of this presentation was on GitHub pages, and it's available by just clicking on the link. Thank you. Any question? Yes?
Do you have a rough sense as to how many tokens were sent for tool calling when you were doing, for example, with discover the comment,
Yeah.
and then which the commenter was, what type of back and forth? Wow. Token tracker.
Yeah, there is this indicator here. Okay. Yeah. You can see that it could be quite a lot because the system prompt is quite big. And if you send all of the commands, like 400 commands, it's also adding a lot of.
You have 400 commands?
In JupyterLab, yeah, but there is a way to filter them with a query, so it's a bit smaller.